Okay, if you remember from a few lectures ago, we talked about different possible ways that a limit might not exist. And one of those ways was if the function was approaching two different values from the two different sides. Let me show you what I mean. Let's call this A right there. And suppose you had a function that was doing this. Okay? In that case, the limit of f of x as x approaches a would not exist. Okay, because it's disagreeing with itself from the two sides. As x is approaching a from the left, the function f is trying to approach this value right here. But as x approaches a from the right, the function is approaching this value right here. And they're disagreeing with each other. So there is no limit of f of x as x approaches a in a case like this. Okay? But what we can talk about as sort of like the next best thing is we could talk about a limit from the left and a limit from the right. Okay, let's just say that this is the number 1 here, and maybe this is the number 4. Okay. Oops. All right, so here's what we can say. We can say as x approaches a from the left, f of x is approaching one. And the way that we write that is we write the limit of f of x as x approaches a from the left. How do I say from the left? What I do is I put a negative sign right there because the left is kind of considered from the negative side, even though these numbers along here aren't actually negative. But that's still the way that we write it. When we say approaching from the left, we put a little negative sign up there at the upper right of the A. Okay, and we say the limit of f of x as x approaches a from the left equals 1. Okay, and what else can I say? I can say as x approaches a from the right, f of x is approaching 4. And I would write that like this. The limit of f of x as x approaches a from the right, I put a plus sign up there, equals 4. Okay? Those are called one-sided limits. Now, the limit of f of x as x approaches a does not exist in this particular case. Because there is not one value that the function is approaching as x approaches a. There's actually two different values. Okay, and these are called one-sided limits. This is just called a limit. Now, once people start learning that there is such a thing as a one-sided limit, then they will oftentimes start calling the one I highlighted in blue a two-sided limit. And that's fine. There's nothing wrong with that. But a two-sided limit just means a limit. Okay? It's not mandatory to add on the phrase two-sided. What is mandatory is that if you want to talk about a one-sided limit, you need to add on that phrase. One-sided limit, or the phrase from the left or from the right. Okay? Now, if for the sake of argument, let's take this piece here and let's move it down to match up there. Okay, in that case, what I've written down there about the right-hand limit, that would be a 1 also. And in that case, the limit would be 1. So do you see something here, a relationship between a limit and the two one-sided limits? Is that if the domain contains values on both sides of A, then in order for there to be a limit as x approaches A, in order for that to happen, then the limit from the left and the limit from the right would have to equal each other. They would both have to exist and equal each other. Okay? Now, let's say that that right-hand part is not in the domain of f, so that what's drawn there is the whole graph of f. So in that case, there is no right-handed limit. You would only have the left-handed limit as x approaches a from the left. The limit of f of x is 1. And in that case, you would still say the limit is 1. It's not really a two-sided limit, is it? But the point is this. For every x that is in the domain of f, as those values approach a, the function is approaching 1. Okay? There's no right side limit to disagree with that. Okay? So these are called one-sided limits, or left-hand limits and right-hand limits. Okay? All right. Let's write down the definition. So I just showed you the idea. Now let's write down the definition. So that's going to involve some epsilon and delta stuff. Okay, I want to start by writing down the definition of a limit, just to remind you. Okay? So we say the limit of f of x as x approaches a equals L if for every epsilon greater than 0 there exists some delta greater than 0 such that if x is in the domain of f and the distance between x and a is between 0 and delta, then the distance between f of x and L is less than epsilon. That's the definition of a limit. Okay? Now, let's adjust that to get the definition of the left-hand limit. Okay? So let's do this. I think it might be actually easier to do the right-hand limit first. Okay, so let's do that. And here's what I'm going to do. I'm basically going to copy what's above. Most of it's exactly the same. So, okay, it's not going to change till we get to the very end. All right, so we say the right-hand limit, so the limit of f of x as x approaches a from the right equals L if for every epsilon greater than 0 there exists some delta greater than 0 such that if x is in the domain of f and okay, now here's where it's going to change just a little bit. So let's look at a picture. Doesn't have to be a very big picture. Okay, let's put an A right here, and let's suppose that let's call this L. Let's draw a picture that would represent a function that is approaching L as x approaches a from the right. So maybe something like this. Okay? So what we're trying to say is that here's our margin of error. Okay? The distance of epsilon on each side of L as x approaches a from the right. I want to say that if I can get close enough to a, then f of x will be inside that green strip. So how close do I need to get? Can you tell? I need to get right there. Once I surpass that, then f of x will be inside that green band. Okay? As long as x is anywhere in between here. And this is our distance of delta right here. Okay? So what do I want to say? I want to say this. Let's start by rereading the sentence, what we have so far. We say the limit of f of x as x approaches a from the right equals L if for every epsilon greater than 0, there exists some delta greater than 0, such that if x is in the domain of f and here's what I want to say, the distance between x and a is between 0 and delta, and x is to the right of a. How do I say that? I say x is greater than a. Then the distance between f of x and L will be less than epsilon. Okay? I want to investigate this phrase right here. The distance between x and a is between 0 and delta, and x is greater than a. Oh, I could just leave it like that. There's nothing at all wrong with the way that is written. But I think we can shorten it a little bit. I think we can put those two things together. Okay? So, if you look at the picture, okay, that part that I highlighted in blue is simply saying that x is between here and here. Okay? Somewhere in there. Maybe I should use parentheses. X is somewhere in there. Okay, the distance between x and a is between 0 and delta, and x is greater than a. Well, isn't a very easy way of saying both of those things to just say this? To just say x is between a and a plus delta, because here's a, and here's a plus delta. So you see, I could do that. I could shorten this by just writing, if x is in the domain of f and x is between a and a plus delta, then the distance between f of x and L is less than epsilon. Okay? Now, in the book, they choose not to shorten it like that. Okay? In the book, what they do is they leave it the way that I had before. Okay? So if x is in the domain of f and x is greater than a, and the distance between x and a is between 0 and delta, then the distance between f of x and L is less than epsilon. Okay? Of course, in the book they use c. I use a and they use c. That doesn't make a difference. I hope that doesn't cause any confusion for you. It shouldn't. Okay? Now, for the definition of a left-hand limit, now it should be very easy. It just requires a very, very small change, and that is just this right here. For the left-hand limit, x is approaching a from the left, so the x values would be smaller than a. So let's just write that out. We say the limit of f of x as x approaches a from the left equals L if for every epsilon greater than 0, there exists some delta greater than 0 such that if x is in the domain of f, and x is less than a, and the distance between x and a is between 0 and delta, then the distance between f of x and L is less than epsilon. That's the definition of a left-hand limit. Okay? So we have a limit, a right-hand limit, and a left-hand limit. If these two equal each other, then that same value would be this. If these two equal two different numbers, then this guy up here would not exist. Okay? All right, now let's just do a little practice looking at pictures and writing down some facts. We're going to do some examples right out of the book, okay? I'm going to write down this function here. F of x equals, now I'm going to write down a piecewise defined function. If you want to write a function that has the limits from the two different sides being different from each other, then there are some fancy ways to make that happen, but the simplest way is to just write a piecewise defined function where the two pieces separate at that point. So what I mean here is I'm going to write a piecewise defined function, and let's say f of x equals 2x. This is example 1 out of the section we're on, which is, by the way, I can tell you what section we're on. It's section 1.4. Okay, and this is example 1. So we have f of x equals 2x whenever x is equal to or greater than 0 and equal to or less than 1. And f of x equals 6 minus 2x if x is between 1 and 2. So what would that look like? I'll show you. Okay, let's say we have 1 right here, 2 right here, let's put those a little bit further apart. Let's say 1 is right about here and 2 is right about here. Okay? All right. Let's put here 2 and 4. All right, so here's what this function would look like. Between 0 and 1, it is a line with a slope of 2. It would look like this. Between 1 and 2, it's a line with a slope of -2 that looks like this. Okay, that's what the graph of the function looks like. Now, we're going to answer 8 questions. I'm going to write all 8 of them down and then we'll find them. Okay, we're going to find the limit of our function as x approaches 1 from the left. We're going to find the limit as x approaches 1 from the right. And then we're going to find the limit as x approaches 1 from both sides. And then we're going to find f of 1 and the limit of f as x approaches 0 from the right, and f of 0 and the limit as f approaches 2 from the left, and f of 2. Okay, we're going to find these 8 things. Okay, so let's start at the beginning. Let's find the limit of the function as x approaches 1 from the left. What is the function doing? The function is approaching that value right there, right? So what is that left-hand limit? It's 2. Okay. Now let's find the right-hand limit. Whoops. As x approaches 1 from the right, as x is approaching 1 from the right, what is the function doing? It is approaching the value 4, right? Because it's coming right along here. Okay? So that right-hand limit as x approaches 1 from the right is 4. Now, what's the limit as x approaches 1? Well, because there's a right-hand limit and a left-hand limit, and they do not agree, that means that the limit doesn't exist. Now, what's f of 1? Well, that's not a calculus problem. That's just an algebra problem. Just plug in 1. Which of these two pieces should I be plugging it into? Well, look. Right there it says if x equals 1, then we should be using this piece. So what would be f of 1? It would be 2 times 1, which is 2, right? Well, you could see that in the picture as well, can't you? See right there? It's not 4, right? Because that's an open circle. All right, now we're asked to find the right-hand limit as x approaches 0. So x is approaching 0 from the right. The function will be coming down here, and it is approaching the value 0. Okay, next we want to do f of 0. So again, when x equals 0, we should use this formula. 2 times 0 equals 0. Also, you can see that right there. Notice they did not ask for the left-hand limit as x approaches 0. And why is that? If x is approaching 0 from the left, you see that's not in the domain of f. So it doesn't even make sense to discuss the right-hand limit as x approaches 0. So in this particular case, since there's, I'm not sure, I might have just said right-hand limit. What I meant to say was it doesn't make sense to approach it doesn't make sense to discuss the left-hand limit as x approaches 0 in this case. From the left would not, I mean, that's just it's a question that's a non-issue in this case. Now, they did not ask us for the limit as x approaches 0. They only asked us for the right-hand limit. Okay, because there is no points in the domain that are on the left of 0, then there's nothing on the left to disagree with the right-hand limit. And in that case, even though they didn't ask us for it, you would say that the limit as x approaches 0 is 0. Even though it's only happening from the right, the point is there's nothing from the left to disagree with that. So it would be wrong to say that the limit as x approaches 0 doesn't exist. It would be 0. Okay, but they didn't ask for that though. All right, let's jump down. We're next at the limit of f of x as x approaches 2 from the left. So we're approaching 2 from the left. The function's going to be coming down here. And the values are approaching 2. And last question, what is f of 2? And what's the answer to that? There is no f of 2. 2's not in the domain. Look up here. Does that say anything about x equaling 2? No. Does that say anything about x equaling 2? No. This particular function does not deal with x equaling 2. So 2's not in the domain. So there's no such thing as f of 2. Okay? Let's do another question very similar to this. Okay. This time I want to do f of x equals x minus 1 quantity squared if x is between 0 and 2 or equals 0 or equals 2, but not 1. And f of x equals 1 if x equals 1. Okay? So let's see what that would look like. That function looks like this. We have a parabola here with a hole in it right at the bottom. And we got a point right up there floating in the middle of the parabola. Okay? So we're going to answer 4 questions here. We're going to find the limit of f of x as x approaches 1 from the left, the limit of f of x as x approaches 1 from the right, and the limit of f of x as x approaches 1 and f of 1. Let's find those 4 things, or determine if either of them doesn't exist. Okay, so again, x is approaching 1 from the left, then the function's coming down here, and the values are approaching 0. Okay. F approaches 1 from the right. The function's coming down here. And the values are approaching 0. Now immediately I can say, because the limit from the left is 0 and the limit from the right is 0, then the limit is 0. Now what's f of 1? It's 1, right? It specifically says that right here. When x equals 1, f of x is 1. You can also see that in the picture. Okay, now let's see if you can do one without the graph. Let's write down f of x equals, okay, let's do this function. 2x squared plus 5x minus 1 if x is less than 0, and sine of x if x is equal to or greater than 0. And we're not going to draw the graph, but we are going to find the limit of f of x as x approaches 0 from the left, and the limit of f of x as x approaches 0 from the right, and the limit of f of x as x approaches 0, and f of 0. Let's find those 4 things. Okay, so the first one, x is approaching 0 from the left. So that means we're using x values less than 0, so we should be using this equation. Now that's a polynomial, so this limit should be super easy to find, because what do we say about polynomials in a couple lectures ago? If you want to find the limit as x approaches a of a polynomial, all you need to do is plug in a to the polynomial. So plug 0 into that, and what do we get? We get -1. Okay? Now the limit as x approaches 0 from the right, that means x values that are greater than 0. So we should be using this function, that formula. And sine of x is also an easy one. If you want to find the limit as x approaches 0, just plug in 0. What's the sine of 0? It is 0. So what's the limit of f of x as x approaches 0? Well, you've got a -1 from the left and a 0 from the right, and those disagree with each other, so there is no limit as x approaches 0. What's f of 0? Look at that right there. Plug a 0 into sine, and what do we get? The sine of 0, which is 0. Okay, so if the function is made up of simple things like polynomials or trig functions, then finding the limits you don't need the graph for. All right, have a good afternoon.